Hello everyone, welcome back. Now today I'm gonna work on a setup on a new sensor that is MXC6226XU. To have a knowledge about this sensor and to see it, let's have a look over the website controleverything.com and here search for the relevant sensor that is MXC6226XU. Now as you can see, this sensor is a digital thermal orientation accelerometer. It's a 4 position orientation detection and shock survival, greater than 50,000 G fully integrated thermal accelerometer, and a lot more features are being provided. As you can see, now you can purchase the sensor from the website and here it is. Furthermore, I am going to interface the sensor MXC6226XU with an Arduino Nano, and for that I require Arduino Code, and here comes the Arduino Code sample. As you can see, now you can download the Arduino Code sample from here as a zip file. This is the link provided here. You can have also the code from GitHub repository that is Control Everything Community. Now I'm gonna have set up some hardware connections so that we can work out with this sensor. In the connections setup, first of all, this here is our sensor that is MXC6226XU accelerometer. It's a digital thermal accelerometer, and next we require an Arduino Nano, which you can see. Now to make a connection among the sensor and the Arduino Nano, this here, an I2C shield is required. It's also available and you can purchase it from controleverything.com. Now gently place the Arduino Nano over the I2C shield. Now what we require to make a connection and among the sensor and the I2C shield is this connecting cable. Make the connection among the sensor and the cable, and while making this connection, make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and similarly we have to follow this for I2C shield. Finally, we need to power up our Arduino Nano, and here comes a mini USB cable into the picture. Now gently push it over the power jack and light it up. Now we are done with the connections part. What we require is an Arduino code so that we can interface our sensor and show it's working. To have the Arduino code, we want to explore the website that is github.com, and there we have to search for the repository that is Control Everything Community, which you are able to see on my screen. Now get it over and here search for the sensor that is MXC6226, and here we get our sensor that is digital thermal accelerometer orientation, as you can see, and here comes the Arduino we are looking forward to explore. So let's have a look over the instructions we need to follow. It says that we have to download and install Arduino software ID on our local machine, and the steps are being provided on this link for the installation purpose. Let's have a look for the better clarification. We can download the Arduino software, we can install it on Windows, Mac, Linux operating system, and all the relevant information are there, as you can see. So you need to follow it carefully. Now get back to the code so that we can have it. As you can see, it's a .ino extension file, and I will be explaining each and every step. And first of all, we have to include the library that is wire.h, and we have defined the address of the sensor that is 0x1c. Now in the void setup function, we have initialized I2C communication as master and serial communication with the baud rate equal to 9600. For the writing part, we have selected the detection register, which is 0x04, and here we have sent the command to power up the device that says that wire.write 0x00. So we are done with this part. Now we require to read the data that has been sent by the sensor to us. So for that we have selected the data register that is 0x00. Now from this very register we have requested and read 2 bytes of acceleration data for x and y axis, as you can see, and the conversion of the data takes place here, which is according to the data sheet, and the details and the formalities we have to follow for that. Now at the very end, after writing, reading and calculation part, we have to display the results we got here onto the serial monitor. As you can see, we have the acceleration in x-axis and acceleration in y-axis. So why not we have a practical working of this code along with the sensor? Let me show you. Now this comes the interesting part to show the practical working. So for that, copy this entire Arduino Code and open up the Arduino. Now here we have to paste this code, as you can see. Here we go, and save the code and name it MXC6226XU, the full name for the reference. And here we go for the verification and the compilation of the code, and we are done. So now upload the code. The code is being uploaded, as you can notice, and it's done. Now check on the serial monitor so that we can have our data displayed. So here we go. You say the acceleration in x and y axis, it's almost stable, which says that there is no motion for the sensor. But when I try to move it, as you can see, the acceleration in x and y axis changes, and it will change continuously as I try to move in the sensor in all the directions for x and y axis, which are perpendicular axis to each other. So this is how the changes are being recorded, and the Arduino code works for the sensor. Now let's have a look over the sensor, the working, the benefits and the features. The sensor MXC6226XU is a MEMSIC digital thermal orientation sensor. DTOS is the world's first fully integrated orientation sensor. Its operational is based on the patented MEMS thermal technology and is built using a standard 0.18 micrometer CMOS process. The DTOS contains no moving parts such as a ball, and thus eliminates field reliability and repeatability issues associated with competitive products. It also eliminates the click sound typically heard in all ball-based orientation sensors. Shock survival is greater than 50,000 G. So due to these features, it's applicable like applications which are cell phones, digital still cameras, digital video cameras, LCD TVs, toys, MP3s, MP4s, fan heaters, cooling fans, and a lot more. Now you can purchase this sensor, and it's available on the website controleverything.com, as you can see, and you can get the code from the resource tab. After that, you can download it. You can also download the code from GitHub repository, and the it's called Control Everything Community. Now for relevant questions and any frequent queries, you can contact us on controleverything.com, and you can post your queries on the community page. To have blogs, articles which are relevant to this video, you can go to instructables.com and search us for this. Now, if you want more videos like this, you can subscribe our YouTube channel. At the very end, I would like to make it clear that for any queries, you can contact us on controleverything.com, and you can fully understand any part of this video or sensor. Now, I hope you have a good day and you enjoyed this video, and a lot thanks for watching.